I was a freshman, I'd be the club was still a little run by Alex Lind, and we'd actually meet up in McBride, and it'd be like 10 of us, and Alex would be just running a presentation on just like on the board and be explaining stuff to us. So it kind of felt more of a class. But I mean, right now we already have 8 people. We definitely have a lot more people than we had when I was a freshman, which was literally
How
just
long
last
would
year.
it like? How long does it usually take? Because I do, I do have like a one coding assignment. I have to do.
We typically try to stick to an hour. Sometimes it's typically a little less. But what coding assignment do you have to do, if you don't mind me asking?
Oh, for 1220. Well, no, 12. No, what is it? 2114. I'm doing lab
Okay, yeah.
6. Yeah, and like I have a project due tomorrow. I have to start on.
Which project?
Study for 2114. Is that the wacky fake one? I think my friends are working on that.
Yeah, I haven't started. I think I might be screwed here, but we'll see.
No, from what I can remember, I don't think it was too bad. I think you just generate a window and then.
Bro, I'm doing lab 6 at the moment, and like all my code is literally like all my code is functional. When I test it, it literally says, okay, failed, and then like 1 pass. I'm like, nice.
Oh dang, man. I'm sorry about that.
Hey, Aiden, how are you?
I'm doing good. Today's actually my birthday, so.
Really?
Ooh, happy birthday.
Hey, happy birthday, bro.
Birthday, man.
Thank you. Thank you.
For everybody that's new here, Aiden here is our treasurer for the semester.
That's
and
me.
Yassine Bensouda here, he's our public relations chair. Hey Miles, how are you?
Bro, I just realized like 3/4 of us who have glasses.
Yeah. Miles, I think I saw your name in the Soul group chat.
Oh yeah, yo.
I'm in that as well.
Yeah.
We can go for 5 minutes for everyone to join.
Yeah, we'll give it a few more minutes. For those of you that aren't in the Discord, I just dropped the link in the chat. You're welcome to hop on.
Can you only log into one instance of Discord?
Probably.
Okay, because I'm having trouble logging into my other computer, and it's logged in on my laptop.
You should be able to, I think. I'm signed in on my desktop and my laptop, so.
Yeah, that's weird.
That's the link to the Google Slides. That's on the presentation right now, if anyone wants to go on.
Also, if you guys want, I can post the links from the slides in the chat.
That would be awesome. And one last link. That last link, I guess it didn't turn into a link, but that last link is for it's just our like new member interest form. But if you fill that out, we can get you onto our newsletter that we have going on. So feel free to fill that out as well. And we'll probably get started here in under a minute. Janet, we could probably get going. 6:05.
Yeah, we can probably. Hey guys, welcome everyone to the third general body meeting of Virginia Tech's Artificial Intelligence and Machine Learning Club. Today we're gonna go over CNN models. It's gonna be a continuation of what we did last class. We went over the lecture video for CNN and we understood how the logic behind convolutional neural networks, and we're gonna apply that and build two small models today. One model is gonna classify images in different classes, whether image inputted in the program is a horse, a truck, or frog, depending on like the classes. And the other model is gonna tell the user whether or not he's wearing a COVID mask or not. So now let's move on. Oh yeah, before we move on, I just want to like talk about like the club Discord and show you guys where you can like find stuff. Let me screen share the Discord. We've like organized it pretty neatly.
There's a lot of new names in here. I appreciate you guys coming out.
Share the screen. Oh, here.
Yeah, towards the end of the semester, I'd love to have more of a networking kind of meeting. So we're planning on getting that together. So, you know, we can actually talk rather than just sit and watch a lecture or hear somebody else talk. But go on, Janet.
Yes, this is basically how the Discord looks. And I just want to go over like this information tab. If you ever want to, this is the welcome page with all the links to all the different types of the Instagram channel we have the YouTube channel, the GitHub, and this is like the new member form. If you go in the meetings info, we have like a mini table showing you when our meeting would be and what will be the agenda of the meeting. So here you can see we have a guest speaker from the Commission on 8th March and etc. etc. On the meeting resources, you can find all the links for the meeting. Here's the link for the Google Docs that we're going to go over today, and all of the links. For example, here's a link to the video of the second meeting that was uploaded to our to our club's YouTube channel. So if you missed that meeting and you want to check it out, you can click over here. And announcements is just where we announce stuff. And general is basically you can talk about stuff. General chat. Resources, you can post like a nice resource if you have. Interesting finds, if you find something that's interesting. Projects you've been working on, and anything random or off topic, and suggestions if you want to improve the Discord or the club. let's go back to the presentation. One more thing that we want to add to this club is weekly Discord hangout. We think that we could, so right now, me and the club leadership position, we're thinking that every Tuesday, 4 p.m. EST, we would hang out in the Discord voice chat, just super informal, nothing planned, no slides, no code planned, nothing prepared. It was just super informal, just people hanging out. And why we decided this is we can play games, talk about AI, ML, talk about projects, network among peers, and we can have constructive debates on random topic, or we can do anything that's also not in this list. It's basically open, like informal, just like hanging out. So we want to do this so that we can know other members and the other members can know each other. So the main purpose is to network among your peers. So that's why we're thinking about this. So we're going to be doing this every Tuesday, 4 p.m. EST. So make sure you join the Discord and be active if you like. And the chat, the link for Discord is over here on this slide. And here's a when to meet link. So basically, so what we are thinking, if everyone's not free on Tuesday 4 p.m., we can even switch it up. So if you guys can go to the when to meet link and enter whatever time you're free. You don't have to do it right now. You can do it later as well. I think I'm gonna like put the link in the Discord and the next email so people can fill that out as well. But for now, the first Discord hangout is gonna be tomorrow, 4 p.m. EST. And after that, from next week, we'll decide depending on the when to meet link and depending on what answers we get. So any questions so far?
I just want to add something to it. And for the Discord, keep in mind, like the Discord, yeah, it's there for announcements, but keep in mind, it's there for you guys as well for networking. So, just like throwing a message whenever you have something or you read something interesting, it's a very, like Jenna said, a very informal setting. So, just talk it up in there.
So now, before we move on to code, I just want to go to like a quick recap of what we did last semester. So not last meeting. So if anyone forgot, they can just catch up. Or if anyone was not there, they can get a sense of what we did. So here's the link to the presentation of last semester. This is the presentation that we looked at. It's basically we introduced neural networks. Just a second. Basically, we introduced neural networks. We went over image, and image is nothing but the pixel values. For example, if it's a black and white image, it's just a pixel value from 0 to 255, depending on the pixel color, whether it's white or black. If it's a color image, it's just basically 3 matrices of pixel values, giving us values for red, blue, and green matrix. And then we looked at the recognizing numbers example on how a neural network functions. And I'll just go to the end towards convolution neural. Yeah, so we looked at how CNN works. So basically you give an input image and it does what's called feature learning. It does convolution layers and applies activation functions such as rel-u, and then does max pooling, and it does it a couple times. After that, it classifies the images, like flattens it and provides softmax, which is nothing but the probabilities of what the program thinks the output must be. For example, if the softmax is 0.5 for cars, 0.3 for truck, 0.1 for van. So that means the program thinks that there's 0.5 probability that this provided image is a car, 0.3 probability that this provided image is a truck, 0.1 that this provided image is a van, etc., etc., etc. And we also went over how the entire logic behind it. So do you guys have any questions on what we did last class, or do you guys want to like go over some specific topic again? Or should we just start making the models?
Yeah, that's completely up to you guys. I know some of you guys are new, or some of you guys just didn't attend last meeting. So, this is for learning. So if you guys feel comfortable, going through this again, then we can go through it again. If not, we can move on.
Okay, I think we'll move on. So today we're gonna make a model. The first model is we're gonna use the data set. I don't know how to pronounce it. I think Cifar 10. and we're gonna use that data set and make CNN. So basically, machine learning is basically taking a bunch of inputs and putting them in a program and then learning from inputs and then making the program learn from itself. So one important feature of machine learning is you need to have the correct data set. And the Cifar 10 is a public data set, which is available to everyone. This is the link to the code that we're gonna build today. The code's already here, but if you wanna build, I'm gonna build one from scratch. So if you wanna follow that, you can just go to Google Colab and click on the first link. It's free, it's a free software, and just have a new notebook. And this is if you don't wanna build and you just wanna follow along, the link provided over here goes to this folder, where if you click over here, do open with Google Colab, it's gonna take you through the already built code that we're gonna go over today. Anyone has any problem opening this?
Guess not. If you guys have any problems opening it, you can probably message me or Aiden in the chat.
Yeah, also in the Discord, if you see any of the officers or any of the members online, and if you want to like especially any of the officers online, and if you want to like ask a question about like the club or anything you like have a question with, just feel free to DM any of them. So firstly, we'll just import TensorFlow. Cannot type today. So the programming language that we're going to use today is Python. But if you don't know Python, or if you're new to programming, or if you don't understand what I'm doing right now, don't freak out. It's going to make sense as long as you know the logic behind it. And as long as you have a rough idea of what I'm doing, you can be fine. Plus, after like everything's done, you're going to have like a nice idea of like what's happening and like how it works and stuff like that. I'm just gonna copy the initial inputs because it's basically just inputting stuff, just importing stuff. So import TensorFlow, we import TensorFlow and Keras module for machine learning purposes, and matplotlib is just for like plotting our data. And I'm also gonna copy paste the first thing because it's, oh no, I'm gonna build the first thing. So first we do trained images. So first we need to input data from our data set. So that's what we're doing right now. We're taking the data set, which is publicly available to us, and we're inputting in the file, and we're going to store them to a variable so we can use them later. So the variable we use is train images and train labels. Train images is going to have a lot of images that we're going to use to train our model. Train labels are going to be labels associated with those images, whether the image is a frog or a horse or a house or whatever. And test images are going to be a set of images that we're going to use to test it. And test labels are going to be a set of labels associated with those test images to test how good of a model is doing. Data set, and we're going to import. So there are two data sets, Cifar 10, Cifar 100. We're going to go with Cifar 10. And then train. I don't know why I have it twice. I think I only need once. Oh yeah, also if you want to press enter, it's going to do a new line, but if you press shift enter, it's going to run the small bit of code. And as you can see, it's downloading the data from the public data set. So you can only, yeah, we're also going to go over if you don't have a public data set, and if you want to like send the code to the file from your own laptop or from Google Drive, how to do that. And now, so the next step that I have done in the code is, I was just like plotting all the data that I have. It's nothing machine learning related. So I'm just gonna copy paste it. Because what I've done over here is, so I've taken the data. So the data that I got from the Cifar 10 data set, I just plotted. So what I did was I plotted all the images and the labels associated with them. So it's nothing AI related, it's just plotting them. Oh, also, while I'm going, if you guys have any questions, just feel free to stop me. Just it's nothing formal. You can just stop me whenever, like, if you have a question or anything. So now that we have inputted data, we're gonna train our model. So to train our model, the first step to train our model, as we saw over here, is feature learning. So we're gonna extract features from the images. Cannot type today.
Hey, Jeanette.
Yep.
I was just playing with the collab notebook. Do you have the GPU turned on?
I'm not sure. How do I check that?
Go to edit notebook settings. I asked because the training is significantly faster.
Oh, okay.
Yeah, edit, go down to notebook settings, and you can click down the GPU. And the training is taking 5 seconds per epoch instead of 60.
Okay. Okay. Thank you. I did not know that. That's what I was
Yeah,
thinking.
the only thing you have to do is rerun the code in the notebook from the start, which no, shouldn't be a problem. What is an epoch?
Is that a question?
That is a question. Anybody want to answer that?
I can answer that. Anybody want to take a guess? We haven't reached that far yet, but after we reach, I'll give you guys a guess if anyone want to guess that. So first, we're gonna tell the program what the filter size would be. So right now, we're just using it as 3 by 3. And then we're also gonna tell the program what the pool size would be. And as we learned over here, the filter size, and those are filter size, which is basically what filter gets multiplied by the image, like what part of the image you take. So now we're gonna start training the model. Model is equal to so we do models.sequential because the model is going to be sequential. It's going to go from left to right. It's not going to have any back tracing. So there are models that have back tracing, but today we're going to go with the basic one, which is just sequential. Now we're going to add stuff to a model. So models.add. First of all, we're going to add a convolutional layer. We're going to add a 2D layer of 32 filters, and the kernel size would be what we mentioned over here, filter size. And then we don't need to worry about strides or padding right now. We're gonna have activation function as rel u, as we learned about that last time. And Oh yeah, input shape. This is the input of the images. So basically, since it's a color image, we're gonna have 3 matrices representing 32 by 32 pixels. So the images are gonna be 32 pixels or by 32 pixels, and it's gonna have 3 different matrices, each representing red, green, and blue value for the image. After we add the convolution layer, we're gonna add the max pooling layer. And then we're gonna specify the pool size that we mentioned about. We're gonna add 1 more convolution layer, but actually 2 more convolution layers. Again, 32 focus. Function would be ReLU. So ReLU is, I forgot the full form of ReLU, but it basically takes the max of 0 and the input. So it disregards all the negative values the number has. So it basically just takes, if the number is less than 0, it's gonna change it to 0. It's gonna cap that to 0. And if the number is greater than 0, it's gonna keep it as the number. Now we're gonna so this is gonna be the 3rd convolution layer. Mm. 64 filters.
So all this code that Janet is doing right now, all these lines he's putting in, these are mostly for, well, they're from TensorFlow. But what we're doing here is we're adding layers to the neural network. So the neural network can look at the features of the picture that we have provided above, as you can see in that little cell above the one he's coding in right now. It's looking at those pictures and breaking it down pixel by pixel. And from pixel, small matrix of pixels, we extract those features, and then we get the bigger image of how we want to classify the later steps.
And like, you guys get the pixel data from like the data that you imported, basically? Is that how the computer understands each pixel?
Yeah. So how Janet said, if you want to do it with another database, we can help you guys out with that. But basically, yeah, all this code is would be the same if you were to import a different database with different images.
Okay.
I don't know.
But these methods are, I don't want to say they're high level, but they do a lot of the gritty work for us. The TensorFlow library is meant for that.
I don't know what's going on. Did I misspell something? Okay, wait.
I think you need another parenthesis on one of the lines.
Sorry.
You're missing a parenthesis on the second line there. You need 3 parentheses at the end.
Oh, my bad.
Yeah.
Oh, it's input shape.
And Jeanette,
Huh?
I'm going to be joining on the Zoom on a different computer at the same time because I want to share my screen as something. Well, when we get to it, I put some extra code in here to show something else.
Oh, okay. Oh, amazing.
So I already had it written, so not that amazing.
Still
So you're gonna see me trying to connect again.
okay.
For those of you that weren't here earlier, Chris Miller here is our faculty advisor. Smart guy.
Very smart guy.
I try.
Okay. So here we learned about feature extraction. So we did this step. So we're done with this step, the feature learning. We had convolutional layer 3 times. We applied the activation function, which is relu, and then we did max pooling. And relu is just, it takes max of 0 and a. I think we have talked about this somewhere over here. But yeah, relu is just takes the max of 0 and a, all the input. So here we're done with the feature extraction learning. Now we're gonna go with the classification, which is the next step. And this is adding different classification layers like flatten. So what flatten does is it basically takes the data that we have and makes it into a one. It takes 2D matrix and makes it into 1D matrix. So it takes the data and flattens it out.
Yeah, and it doesn't necessarily have to be a 2D matrix, but you know, depending on how big your neural network is and how detailed you want to get into it, how deep you want it to be, you're going to have more nodes in your neural network. And so when you're going through the feature extraction layers, you're adding more layers. So you can see how complicated and complex it can get with the layers. So when you want to classify it, you want to get that down to a more simplified version of all the data you had, all the computation you did. And so you get that into a 1D matrix, and that's easier to compute.
So here we did the classification. So here we did feature extraction. Here we did classification. Now, since we're done with model, I'm going to do model.summary to print out a summary of like the entire model of what we have so far. So far we have a sequential model with a convolution layer. Then we did max pooling. Then we another convolution layer. Then another max pooling. One more convolution. One more max pooling. Then flatten it out. Then we dense it a couple of times. Then we flatten it out again. Dense it a couple more times. And this is how our model is looking so far. It has a total of 74,772 parameters. So as we looked over here on the first example, this had 784 inputs. And it did it had hidden layers and gives us output. We already have input. The other input is all the images that we inputted. We are done with the hidden layers, which is the convolution layer. We did feature extraction and classification. Now we just have to test and build our model. We're done with coding our model. Now we just have to build our model. So now we're gonna train build the model. First, we need to compile it. So model compile. So how does the model learn? So it's gonna optimize itself. We're gonna specify what optimizer to use. We're gonna use Atom because it's widely used and it's efficient. But the optimizer that we learned is gradient descent. It's basically finding the steepest slope at any point of the graph and like chasing that graph to get the local or global minimum of the graph so that the model is more efficient. Now we're gonna define the loss function, which is loss basically cost of the model. So here we use sparse categorical cross entropy. If we use, so there are a couple we can use. We can use either sparse categorical cross entropy. There's also categorical cross entropy. We have a lot of options. If you just like press dot and you can like hover over it, a lot of options gonna pop up. And it's so the reason why we use sparse categorical, because if we have different classes with different inputs, as in we need one, as if we need to find one class, we have a picture and when you identify the picture, That's when sparse categorical cross entropy is useful, because that's going to give us a output. That's going to give us one output. And we can also use categorical cross entropy if we need different probabilities for all the different classes. If you need, oh, this class is going to be 0.5, this class is going to be 0.4, this class is going to be 0.3. If you need that, we need to do categorical cross entropy. Yes. And then matrix is basically what we're going to judge our model on. We're going to judge it on the accuracy. And now we're gonna run our model. Model not fit. So we're gonna the model is gonna take the training images and training labels that we specified all the way in the first step. And now we come to epochs. If anyone want to take a guess on what that is, they're free to. And then validation data. So anyone want to take a guess on what epochs is?
I put it in the chat, Jenna, a little earlier.
Uh,
But I'll just read off what Aiden put in the chat. So an epoch is one cycle through the full training of the data set for the neural network. So yeah, like Daniel said, they're like iterations when you're passing through the data and you're training and you're optimizing.
So I'm gonna run it, and I'm also gonna talk about this. Something's wrong.
You misspelled compile.
Oh, I cannot type today for some reason. Okay, so it's gonna run. This is the first time it's gonna running out of the 15 times. So let me first explain what we did all over again, just giving a bigger picture. So we took a bunch of data from a public data set, we put it in our program. Now, what the program is gonna do is it's gonna take the data, it's gonna learn from the data over and over again. It's gonna analyze the image and take a guess of what that image is. And the accuracy over here is the accuracy that it has over the training data. So the data that we input. So let's say we gave the model like 500 different pictures of different classes. That's accuracy is what the model is guessing the accuracy is how many times the model is right on its guessing, and validation accuracy. So now the problem with accuracy is, so you take a bunch of data and you learn from data. So, but the actual implementation of your model is only as good as the guesses it can make on data it has never seen before. Like if someone can show you a same apple 100 times and make you memorize that that's an apple, but now if tomorrow someone shows you an apple which is a different shape, different color, different size, and if you can guess that that's an apple, that's called learning, and not just seeing the same apple 100 times and guessing that it's learning. So for that, we need validation accuracy and validation loss and validation data. So validation data is the test image and test labels that the model has never seen before, and it's gonna make guesses on new images, on new labels that it has never seen before. So that's what's validation accuracy and validation loss is. And accuracy is just on the training data that it has seen over and over again. So as you can see, the more times we run the code, so initially the accuracy was only 0.31, but after we ran the code 15 times, after the model iterated itself 15 times, the accuracy increased to 0.80, and the validation accuracy went all the way up to 0.7 and then decreased 0.67. So validation accuracy is what we need to focus on, because that's how good your model is, basically. So now if we increase the epochs to 20, or let's say 25, and let's see what happens after 15 epochs and what happens to the accuracy. Also, if you notice, last time we got accuracy as, yeah, so the model's gonna run from it. So yeah, so it's gonna learn. So let's wait and see what happens. Also, so the next step for this is it's modeling validation accuracy and accuracy. So I'm just gonna copy paste the code because it's not related to ML, it's just plotting it. So and after that, I'm gonna explain what validation accuracy and accuracy does.
Yeah, just a sad comment. I think how can you understand Epoch? Just maybe as an example, I want to introduce you. I want to introduce my girlfriends to all you guys, and the Epoch is like. So I introduce her by show you guys her photo. Like Epoch is like how many times I show the same photo to you, and I heard, I think there's a word iteration, and the iteration is maybe I say like 10 her photo in my phone, and I want to show you all of them at this in one epoch, I mean one time, but I only can share one photo at a time. So in one epoch, I like share one single photo one time. I mean, so I share you 10 times for one epoch, I mean, a batch of photo. So I don't know if I explain it clearly, but the iteration is, and the epoch is different. It's like a batch of things you do that several times, or a part of epoch. Um, Sorry, I'm not good at explain things. Just
No, you're fine. I think that made sense.
Yeah, that
But
makes sense. So basically,
yeah.
Epoch is how many, the entire data. It's gonna take the entire data set and go through all of it at once, and that's one epoch. And then it's gonna go to that again. So here, as we can see, it went to 1,563 images, and all of them at once. It did not repeat any of the images. It could have if we set it to repeat, but not in this model. It did not. So it went through all the 1,563 pictures, and then it did it over and over again in different epochs.
One thing I want to add with the training, when you run the training again after you've already run it, you're going to get funky results like you see in that graph, where it's actually continuing during epochs. It's like training again. It's kind. I've run into this before, and so I just had to reset the runtime for the Google Colab and just run it again for the. I'm doing it for 30 epochs.
So just refresh the page.
Oh, you can go up to runtime and just do yeah, factory reset runtime, couple down. Yeah. And just rerun the cell.
I noticed the first one was that I wanted to point out that the first accuracy was 0.3, and the next time we run, it's not going to be 0.31. It might be something else because it's based on probabilities and stuff.
Yeah, I noticed that it started, for me, it started at 0.8 the second time I ran it. And I was like, something's wrong. So I have to reset it so it recompiles the model instead of using the same one that's already been trained. I've run into this before in another project. That's how I was able to spot it. Okay, now the graphs look right.
So the very first time we ran, the accuracy was 0.30. Right now it's 0.23. So just for, so it's not going to be the same every single time. Should change this to 15 or something. Do you guys have any questions so far?
Here's something to ponder. Maybe you can have some insight. The accuracy is going up, but the validation accuracy is about staying the same. You have any thoughts on that?
Anyone want to answer that? I think someone put something in the chat. Overfitting. Yeah. So I think Daniel answered it in the chat. He said overfitting. So when the accuracy goes above validation accuracy, the model overfits the data. So basically, when you have a big model, when you're trying to make a ML model and there's a certain amount of data, the model's only gonna learn from that amount of data. So if all the data has a bias, for example, if you want to do face recognition and all the pictures that you have in the data are all pictures of, let's say, white people, the model's not going to run very good on like faces of like brown people or different colored people, because it's going to overfit the data. So it's only going to run good on white people because there's a bias. Validation accuracy is the accuracy of a model to run on the picture outside of the training data. So that's why we can see validation accuracy is not going up, but accuracy is. So it's getting better and better to learn from the same set of images that we provided, but it's not getting better. The model's not getting better on the overall, on its like overall making guess. And this is one more. Wait, let me. So these are a couple of graphs to think about.
Yeah, that's one that I added.
This one?
Yeah, the one that's diverging, the very first one. You scroll up.
This one.
Yeah, that's one that you tells it's overfitting, because if your validation and training loss values diverge, that's a big sign of overfitting.
Yeah.
And so that's how we can tell. So the guess earlier about overfitting was correct.
Yeah.
So I didn't realize me playing with this file messed with the file you're looking at. My apologies.
No, you're good. You're good.
Yeah, so that file we shared, I think we on the executive board, we have access to edit it, but the link we provided for other people outside of those specified people, they can only view, so they have to create a copy. So, because I went on that file as well, and I saw Jenna was running something, I was like, oh.
Oh, that explains it.
Yeah. Yeah, so now we're gonna check how our model is performing. This is the code to input a. This is the code. So what this code does, what something's wrong. Okay. What this code does is it lets us input an image from the internet and play it in the model and let the model take a guess on what that image is. So I'm just gonna search up a horse image. Let's say this is a horse. Just copy link address. I put the link address over here. It's extremely big. And when I paste it, the link address is.
You're copying the link address rather than the image address.
That makes sense. and it's gonna make a guess as a bird. It is a horse, but it's gonna. So sometimes it's not gonna work. Main reason it's not gonna work is because the images that we provide are, it's 32 by 32 bit. As you can see, this is a clear image, but the images that the model sees are only 32 pixels by 32 pixels. So that's also gonna create a huge bias. Let me try with a different image. Hopefully this works. This is pretty big. This is definitely not this. So this is definitely something wrong. Let's take this one. I don't know what's happening. I don't know what's happening, but yeah, if you take an image and try running into a model.
Did that say aeroplane, bro?
Sorry?
No, I saw somewhere there, like it said an aeroplane. I'm like, what?
Oh yeah, because one of the classes would be airplane, and as I said, the image is only like, the model only sees 32 by 32 bit, so it might not like understand what's like happening. But yeah. I don't know why this is so long. Definitely copied the wrong thing. I'm gonna- It's gonna be
Janet, I think you should just delete the whole block of that and then
what
just
it is.
copy from the.
That's- Oh yeah, see, it's a horse now. This image works. So when I use this image, which is, so when I use this image, so this link responds to this image, the program outputs as the horse. So our ML model knows that's the horse. So yeah, this is the model. This is our first model. Any questions so far? I'll take that as a no. Yeah, let's move on. So now the next thing that we're supposed to do is face mask detection, but I don't think we're gonna have time for that. So
Wait, no, dude. So like, does it like, how does it access the image and analyze it? Like, will it like open it like on the program itself and then reference it, or like? So you copied a link, right? How does the code like check it? Like,
oh, here's the code for that. This is what, so I put it in the we made a function called classify online images, and we put it in classify online images, and this function puts it takes the image, takes it into, it reshapes it into 32 pixel by 32 pixel, and it's like a color image. So it's gonna give us 3 matrices and puts all this, like the new 32 by 32 pixel image that it
oh yeah, all right. Oh yeah,
and
okay.
put it in.
I didn't see the method.
Yeah, so I don't think we're gonna have time for this, but I have attached the link to the complete code. And so luckily I found the data set of people wearing a mask and not wearing a mask online. So here's where I found. But the thing is, yeah, so it's shared with you guys, so you can feel free to use it. And this is 3 models. So I've separated into 3 different files, but you can combine into only one file. The first, data pre-processing, is it basically processes data. What it does, it takes the input of the file, since the data set has files of different sizes, different size, different face, different color and stuff like that. So it's going to take all the images, turn it into black and white, and then put it into a dictionary with like label with the image and the label associated with it. and then save them. And what the second file is going to do, it's going to train the CNN, and the third file is going to detect. So third is not important if you don't want to do it, but what the third file does is it's going to access the camera on your like device, computer or laptop, and it's going to open like a camera window, and it's going to tell you whether you're wearing a mask or not. So it's basically a loop. It's a infinite loop of taking pictures from your video camera and telling you whether you're wearing a mask or not. So you can try it out if you like. I don't think we have time for that, but yeah, this is all the files. This is the data file. I don't know who made this with mask, but the pictures are funny. Yes. Oh yeah, one more thing. If you guys wanna, lastly, let me just conclude the meeting. After that, we'll talk over that. So I want to talk about the next meeting. So next meeting we have is on 8th March, so which is upcoming Monday, 6 p.m. EST again. So for the next meeting, we have a guest speaker from Deep Cognition, and we're still in the talking stage, but we're talking about having like prizes, giving like prizes and like giveaways to like people who attend. So make sure to attend, and they're gonna talk about AI and how the business related AI and stuff like that is, and how the corporate world is doing and what they're hoping for. Because at the end of the day, we're all gonna like graduate college or like and go in research or join the corporate world. So if you want insight on like what's happening in the corporate world right now, what are the companies looking for, what are companies aiming for, what are their struggles relating to AI right now, and stuff like that, this is a very interesting meeting to attend. There also going to be an open Q&A, so you can ask any questions you like, and so be sure to attend the next meeting. And after, yeah, so
Yeah, let me just build off of that real quick. Yeah, we're trying to make this kind of like we hold the lectures bi-weekly. We want to have more so like networking opportunities on the weeks that we don't meet, also at a bi-weekly rate. So like Janet said, we have this next Monday for those of you that want to attend. There will be prizes, and like Janet said, valuable information for those of you that want to go into the field of artificial intelligence and machine learning after graduation. And then for the 22nd, we're also hoping to bring in an alumni to speak in regarding AI and ML. But that just goes to say this is very much a communal thing. So, if any of you have connections or people that would be willing to come to talk to us, because, we're obviously, like Jenna said, we're all learning. We're all going to graduate at one point. Don't hesitate and, hitting anybody on the e-board up to, let us know that somebody that's coming that would be willing to come and talk to us. Thank you.
so thank you for coming to the meeting. I will see you on 8th March or tomorrow if you guys decide to attend the Discord. You have a weekly hangout. I'm gonna share the when to meet link in the Discord soon, and it's also gonna be on the next email, the follow-up email. And also, if you guys wanna learn about how to like input data set into your Google Colab, like if you have a data set. So over here, we just inputted the data set from online, like it was publicly available. But if you have a local data set like this one, and if you want to input in your model, if you want to learn that, stay back, or you're free to go if you want to go.
Thank you.
Thank you.
Yeah, thanks for coming
attending.
out.
So if
Thank
you
you guys.
Thanks for coming out.
Thank you.